How do you control a weapon traveling 10 times the speed of sound when it's trapped inside a literal ball of fire? The answer is simple, but absolutely terrifying. You don't, at least, not in any way we've ever understood before. We are talking about Mach 10, over 7,000 miles per hour. To put that in perspective, at that terrifying speed, you could fly from New York to Los Angeles in less than 25 minutes. But as this invisible monster tears through the atmosphere, it isn't just fighting gravity. It is fighting the very laws of physics. It hits the air so hard that the friction becomes a weapon of its own. We're talking about temperatures reaching a staggering 3,000 degrees Celsius. That is more than half the heat of the sun's surface. It is a heat so intense it can liquefy the hardened steel of a tank into a glowing puddle of soup in seconds. It's a temperature that shouldn't just melt the machine, it should vaporize its very brain. But here is the real nightmare. Controlling a hypersonic missile at Mach 10 is like trying to drive a high-performance race car, but with a terrifying twist. You are completely blindfolded, your brake lines have been severed, and you are screaming through the heart of a solar storm. This is the blackout cage, a speed so violent it creates a wall of silence, a sheath of superheated gas that swallows every radio signal, every GPS coordinate, and every desperate command from mission control. For those agonizing minutes, the most advanced weapon on Earth is a ghost, a white-hot ghost that is effectively blind, deaf, and alone. So, how do you steer a fireball when you can't even hear it scream? Find out, we have to look at the moment the air itself begins to shatter. At Mach 10, the very atmosphere you're flying through stops behaving like a gas and starts acting like a solid, impenetrable wall. This is the moment physics breaks. To understand why this weapon is so lonely in the sky, we have to look at what happens to a single molecule of air when it meets a nose cone traveling at 7,000 miles per hour. Ordinarily, air molecules are polite. They see an object coming and they simply move out of the way. But at these extreme speeds, they don't have time to move. They don't have time to flow. Instead, they are slammed together with such unimaginable force that they are literally crushed. This is the beginning of the buildup. This is where the compression becomes a weapon. The air is packed so tightly against the leading edge of the missile that it triggers a violent chemical reaction. We are talking about the air itself being shredded. The intense pressure and friction rip the nitrogen and oxygen molecules apart, tearing the electrons right out of their orbits. This is ionization. In an instant, the transparent air around the missile is transformed into a thick, glowing sheath of plasma. This isn't just fire. This is a superheated, electrically charged soup that completely encases our steel monster in a shroud of white-hot energy. Imagine this missile as a screaming giant, a multi-million-dollar masterpiece of engineering, roaring through the upper atmosphere. But as it accelerates deeper into the Mach 10 range, that scream is suddenly muffled. The atmosphere isn't just fighting the missile's progress, it is building a cage around it. This plasma sheath is a perfect electromagnetic shield, but it works both ways. It is a one-way mirror where the world can see the fireball, but the fireball can't see the world. Every radio wave, every GPS coordinate, and every command from a satellite thousands of miles above is stopped cold by this wall of ionized gas. For the engineers back at Mission Control, the telemetry screen goes flat. The steady pulse of data, the heartbeat of the weapon, simply vanishes. This is the stage of the flight where the silence begins. For several agonizing minutes, the most advanced piece of technology ever built is effectively cut off from the rest of humanity. It is screaming through the sky at Mach 10, but it is doing so in a state of total, terrifying isolation. To put the violence of this environment into perspective, look at the energy being generated by the friction alone. Every square inch of that nose cone is being bombarded by a heat so relentless, it carries more kinetic energy than a freight train hitting a brick wall. This isn't just enough heat to make the metal glow. It's enough energy to melt a solid block of concrete into a liquid puddle in the blink of an eye. If you were inside that missile, if you could hear anything over the roar of the atmosphere being torn apart, you would realize that you are riding a lightning bolt that has lost its mind. There is no radio. There is no radar. There is only the heat, the pressure, and the crushing weight of the blackout cage. The missile is screaming, yes, but the electromagnetic shell it created has become its own personal silencer. Every sensor on board is suddenly blind. Every antenna is useless. The guidance computer is frantically searching for a signal, any signal, that can tell it where it is or where it needs to go. But there is nothing, only the static of the plasma. This weapon, designed to be the ultimate predator of the modern battlefield, is now just a blind ghost. It is a terrifying paradox, a machine that is moving too fast to be caught, yet too fast to even know if it's on the right track. As the pressure builds and the temperature continues to climb, the structural integrity of the weapon is pushed to its absolute limit. The air molecules continue to disintegrate, fueling the ionization storm that keeps the missile locked in its silent prison. We are witnessing a battle between human ambition and the fundamental rules of the universe. We want to go faster, but the universe demands a price, and that price is communication. That price is control. For those watching from the ground, the missile is just a streak of light, a man-made shooting star crossing the horizon. But inside that white-hot halo, there is a digital struggle for survival. How do you maintain a flight path when your eyes have been plucked out? How do you reach your target when you've been thrown into a sensory deprivation tank at Mach 10? Where the tension in the control room is thick enough to touch. They know where the missile was. They know where it's supposed to be. But right now, in the heart of the ionization storm, no one knows for sure. The energy is staggering. The isolation is absolute. The missile is a screaming monster in a world of silence, fireball in a cage of its own making. It is the ultimate impossible task to move this fast, to hit this hard, and to do it all while being completely, utterly alone. But what if I told you that this silent, blinding cage wasn't just a failure of physics? What if the very thing that makes this weapon blind and deaf is actually the secret to its greatest strength? To understand that, we have to look past the fire and see the ghost hiding inside. But what if I told you that this silent, blinding cage wasn't just a failure of physics? What if the very thing that makes this weapon blind and deaf is actually the secret to its greatest strength? To understand that, we have to look past the fire and see the ghost hiding inside. Because here is the twist. The moment where the nightmare of the blackout turns into a strategic masterpiece. This sheath of superheated gas, this violent plasma that cuts the missile off from its masters, is actually a natural invisibility cloak. Think about how radar works. An enemy stationed on the ground screams a radio signal into the sky, waiting for it to bounce off a metal object and return with its location. It is a game of digital Marco Polo. But when that radar beam hits a hypersonic missile at Mach 10, it doesn't find a smooth metal surface to bounce off of. Instead, it hits the plasma sheath, and plasma is a glutton for energy. It doesn't reflect the radar waves, it swallows them. The ionized gas absorbs the signal, scatters it, and leaves the enemy radar searching an empty sky. On their screens, there is nothing. No blip, no warning, just the clear blue void. The missile has become a stealth shadow. It is a ghost made of fire. This is the ultimate aha moment for military engineers. By moving so fast that it destroys the air around it, the weapon creates its own shield. It's a paradox that seems impossible. The hotter and more violent the flight becomes, the more invisible the missile gets. The very thing that should be screaming its position to the world is the very thing that makes it vanish. But we still have the problem of the blind pilot. How do you hit a target 1,000 miles away when you are trapped in a sensory deprivation tank? How do you maintain a precision of mere centimeters when you can't see, hear, or feel the outside world? This is where the impossible task meets human ingenuity. To solve this, engineers had to stop looking outside the missile and start looking deep within it. Enter the world of inertial navigation. Imagine trying to walk across a pitch-black room. You can't see the walls, but you know where you started. You count your steps. You feel the tilt of your body. You know how fast you are moving. This is exactly what the missile does. Inside its core, shielded from the 3,000-degree heat, sits a cluster of hyper-precise gyroscopes and accelerometers. These aren't your everyday sensors. They are masterpieces of mechanical engineering, capable of detecting the slightest vibration, the tiniest shift in the wind. While the plasma storm rages outside, the guidance computer is doing millions of calculations per second. It knows where it is, because it knows exactly where it was 1 millisecond ago, and it knows precisely how much force has been applied to it since then. It is a digital memory so perfect that it doesn't need to see the stars or hear a GPS satellite. It is navigating by pure logic, following a pre-programmed ghost path through the sky. But even a perfect memory can drift. After hundreds of miles in the blackout, the missile needs a reality check. It needs to see just for a heartbeat. And this is the most brilliant part of the entire process. We call it the plasma window. The engineers don't just wait for the fire to die down. They force it to move. Using powerful magnetic fields generated from inside the missile, they can literally push the plasma away from a specific point on the fuselage. Think of it like a magnetic squeegee clearing a patch of ice off a windshield in the middle of a blizzard. For a fraction of a second, a mere blink of an eye, a small hole opens in the fireball. In that microsecond, a sensor peeks out. It catches a glimpse of the horizon, grabs a single GPS coordinate or scans the terrain below. And then, before the heat can melt the lens, the magnetic field shuts off and the plasma cage slams shut again. It is a maneuver so precise it makes skipping a stone across a pond look like child's play. These peaks are calculated to the millisecond. They are the only moments of connection in a journey defined by isolation. And they are enough. With that one tiny piece of data, the computer recalibrates, corrects its course, and dives back into the silence. The result is a transformation that defies belief. What started as a chaotic, tumbling ball of fire in the upper atmosphere has been refined into a stealth arrow. The violence of the Mach 10 air, the crushing heat, and the electrical storm of the ionization, all of it has been harnessed. The missile is no longer a blind monster. It is a calculated phantom. When the fire finally begins to fade as the missile slows down for its final approach, the transition is almost poetic. The roar of the plasma dies down into a subsonic whistle. The cage dissolves, and for the first time in the flight, the radio signals crackle back to life. But by then, it is already too late for the target. The ghost has already arrived. This is the beauty of hypersonic engineering. It's not just about raw power or terrifying speed. It's about the intelligence required to survive the very environment that speed creates. It's about turning a blackout into a shield and a blindfold into a map. Or it's the relief of seeing a plan work perfectly against the most hostile forces in nature. But as brilliant as these plasma windows and inertial systems are, they are just one piece of a much larger global puzzle. Because while the physics are the same for everyone, the way we use them is sparking a race that is changing the very nature of war. To see where this ghost flight is taking us next, we have to look at how the rest of the world is trying to catch the uncatchable. But how did we ever reach this point? This journey didn't begin in a modern lab. It started in the late 1950s with a rocket-powered needle called the X-15. Back then, pilots weren't just testing planes. They were testing the absolute limits of human courage. They were the first to feel that terrifying transition where the sky turns black and the wings begin to glow. It took decades of charred metal, exploded engines, and heartbreaking failures to turn those early experiments into the Mach 10 phantoms we see today. Now, that race has evolved into a high-stakes duel of engineering philosophies. Take Russia's Avangard. It is designed to lean into the chaos, using the thickest possible plasma sheath as its primary invisibility cloak, a blunt force ghost that is nearly impossible for traditional sensors to track. Then look at the American approach with the Dark Eagle. It is a surgeon's knife. The focus here is on extreme glide precision and advanced thermal management, treating the blackout cage not as a blind prison, but as a window that can be opened and closed with mathematical certainty. Two different paths, but one shared reality. The physics of the plasma cage do not care about national borders. The nation that truly masters this ionized storm doesn't just win a race, they rewrite the rules of global security. In a world of hypersonic flight, the old shields of the 20th century simply melt away. If you can't see it coming, you can't stop it. If you can't hear the scream, you can't find cover. Mastering the blackout is the ultimate test of trust. Trust in the algorithms and the materials we have forged to survive the most hostile environment on Earth. But what if this technology eventually moves beyond the battlefield? Imagine a future where the plasma cage isn't a cage at all, but a bridge. A world where you could travel from New York to London in less time than it takes to finish a meal, riding a controlled shooting star across the edge of space. We are standing at the threshold of a new era where we have finally learned to navigate the fire. The only question left is, how much further are we willing to push?